We can now replicate this process. Let's go back. Frame change default. And now we can replicate this process, and just all we have to do is basically say we now do this with random effect. We say random effect, or we copy this and we say MLE. And if you're already an advanced user, you can also loop this part in saying, let's run a model with all these subscripts. And so let's say you can do all of this. Let's just do this all in one go. So all random stuff. So this is our results export block, in which we start from scratch, create a frame, define our independent variables, and for each of these independent variables we run different models, right? So this is just an example, right, which is very case specific to the stuff I'm presenting. But I can tell you that once you have this kind of stuff set up, this is it. Now what we have is, for each regression model, fixed effects, random effects, MLE results, we have now a very neat table of our regression results, which are fixed effects, variable results, random effects results, etc. And once you start creating this kind of stuff, you can start doing quite a lot of interesting things, in the sense that we have not destroyed our raw data set. All we've done is that we are now pushing all our results to a new frame without having to, replace our original data or do crazy types of export combinations for our result analysis, right? And so this kind of workflow helps a lot with all of this, right? And there's also other things that you can do, right? So you can say, let me just show you another example. Let's just take the vanilla regression, right? So we are not interpreting the coefficients, but this is for your result. As I said, if you do return list, it shows you this matrix has been saved, and you can say matrix list R table. This is a matrix. So this is a matrix that contains everything, right? And it has a matrix that has all of this included. Yeah. And we can also export all of this. So again, I'll share the do file with you guys, so we are not wasting time on discussing all of this. But you can create something. I'll just copy paste this from my file. So we can also export stuff, because we have an index, we have a matrix with specific indices. So you have grade, age, tenure, south. So if you say matrix list R table, right, you get this. But you can say matrix R table 1, 1, or tables 1, 1. Oh yeah, you need to say display, which is weird. It should be able to do this. Okay, in any case. So basically you're saying display the first element of this matrix, which is a beta coefficient. And if I say display the second element of this coefficient, we get this variable, right? And so there are quite a lot of user-rated programs which are generating these matrices of results, and then most of the time you have to deal with these indices. So you have the first row is your beta. In this case, in the default Stata case, maybe you need the lower bound, upper bound, or you want the critical value of all of this. And so again, you can automate this process, which means we are creating a new frame called index, in which we have the variable name, mean, standard deviation, lower bound, upper bound of the confidence interval, right? And then basically what we are saying is that once we run this regression, let's do this again. let's run this declaration again. And then basically we can say something like this. For each x in these variables, and we also add constant. So I'm not doing the other loop. We say frame post index test, the variable name, which is this. Then we need the mean variable, right? So we have the mean variable, which is r table 1 1. So r table 1 1. Then the standard deviation is the second variable 2 1. Then the lower bound is our fifth row, and the upper bound is our sixth row, right? But these numbers are changing. So if you look at our table, so we want grade is number 1, age is number 2, tenure is 3, 4, 5, right? So we are looping over names, but this index is going in numbers. Again, this is a slightly complex example. So we can say local I equals 1. We replace this with I, and also I, right? So which means it's saying that if we use grade, I equals 1, right? We want to say that if it goes to age, I should be equal to 2. So we can do two things. We can say local I is equal to I plus 1. So if we increment this, for grade takes 1, age takes 2, tenure takes 3. So the indexes are homogeneous. Or a more nicer way is you just say local plus I, which is, let's say, a nicer way of incrementing everything by 1. Yeah, we use this in programming all the time. So this is another example. Let me just show you what it looks like. B to be bound in parentheses. Okay, something is not happy. So we are missing a bracket here. Correct bracket. Correct. Right. So yeah, again, we get no information if it worked or not, but since we get no error, it worked. So we can say we can now do frame change. Yeah. And we look at this, we will see that our coefficients have been exported to these frames, right? And again, this is one example of how one can do with this. Again, if you are already advanced enough to be doing this kind of loops with locals and stuff, this is relatively easier to adapt to your workflow. But this, to me personally, has been the biggest plus point of frames, in the sense that we have been able to export results to a different frame without having to modify all this. And then you can play with these results, you can visualize them, you can plot them, you can use even in QF plot, etc., which is used a lot for, you can use this kind of results to plot your data sets. It also helps you organize your results. So you can have a model run, you can organize by model, you can organize by coefficients. It just makes life much more easier to visualize these results. So the last thing I would do that I would like to work with is how to link frames. Yeah, linking frames. And so this is already the main thing that should be that you can use quite a lot. So we start with completely blank slate. We use family, so it's a Stata data set, and it's a very interesting data set, right? It's an interesting data set in the sense that it has two variables. You have a person's ID. So let's take this person, 14982. Let me make this bigger. So you have a person ID 14982. And now this person has a mother and a father whose IDs are also attached. Yeah. And this person, the mother's ID. So mother also exists here in row 431 because she also has her mother and father. So the grandparents of your first person. And this kind of data sets are fairly usual if you're doing ground survey analysis where you're doing village surveys or community surveys. And so this is the data set in which a person is being explained by another person who also exists in the data set, right? And so let's see how we can use frames to deal with this. So we can say frame create family, right? So we create another frame and we say frame family web use family, right? We reload the data set as it is in another frame, right? What we are then basically saying, if I do frames directory, we have two default frame and a family frame which are exactly the same because we've just reloaded the data set in all of this, right? Like I said, and so what we will do is because we have this person, let's take this person. So we say something like list PID star if PID equals. So this is the person ID whose mother's ID is this, whose father ID is this, right? Let's take the PID of the mother, right? So we do this if this, right? So this person whose observation number 8 is linked, whose mother exists on observation 431, right? And then this mother, this person's mother, right? So let's look at her. Let's look at her. She also has attributes defined in these variables, right? So, and you maybe want to add these attributes back to your original person. Maybe it's the, I don't know what this variable stands for. Maybe this is the income or education level or qualification, etc., right? That is affecting other outcomes of our person of interest, right? And so this is a complex data set in which we have sort of like a many-to-many kind of comparison in this data set. So what we are saying is that we will create a link. So we say fr link many to one because the person can exist multiple times on PID underscore m because this person could be a mother to multiple people, right? So it's a many to one. And then this PID m from our main data set, we link it to the family data set with PID. And this is different from a different other merges with Stata, in which the variable needs to be exactly the same for you to merge it. In here, what we are saying is take this variable, yeah, which could contain duplicates, which could contain missings, but merge it in with family with the PID variable. Yeah, so we are merging variables with two different names, which you cannot do in a standard Stata merge. And then basically we say generate mother. Okay, and so we basically generate this variable mother in which we say that, okay, this person's is linked to ID 431M. So we know this person exists on row 431. And similarly, we can do the same with the father. And we can say father, right? And so we'll get the IDs of the mother and father, and then you can do quite a lot of things, right? Once you have generated this information, right, you can use this variable called frget. You can say frget, get the mother's mother, the grandmother information equals PID underscore m mother. So basically what we have done is that we have now said that first link the two data sets in which we are getting the information from the variable mother. And then we are saying use the information that we have generated, get the mother's ID from this row, right? So which is again this column, but for this observation. So again, one needs to wrap one's head around the logic of this, but we are now doing much more complex merges across frames by linking them together. And this allows us to do many other things, right? So we can also get variable names. So we can get x1 to x4 of the mother into this variable. We can get x1 to x4 of the grandparents. And then we can start building more complex data sets as we go on. Yeah. And then the last example I want to show you guys is how to generate variables. So I will do something very generate variables based on another frame, right? So here we are linking, and I will just show you a simpler example, so which is not as confusing as all of this, right? So we clear everything. Let's just do clear all. We use sys use auto. And then we basically say gen ID is equal to underscore n. So we have a unique ID for each row. And then we say, right? So we have ID for each row. This is unique, right? And then we say frame put ID into another data, right? So this is, we just generate a new frame into the fly. We say frames directory, and we will say we have our default data set here and we have another data set here. Yeah. Frame change another data. The only thing common between this data set and the other data set is the ID variable, right? And so this is just an example. So we say frame change default. So what we do is we say frame other data. Let's just generate some junk variable, some random variable. So we just do it in a block. We say gen x1 equal to r uniform. Gen x1 is equal to r uniform. Gen x2 is equal to r uniform int, right? So r uniform int is just giving you an integer. So double generate this. And so another data, sorry. Invalid syntax. Frame another data, gen double x1 equals to r uniform of int. Normal, why is it unhappy? So okay. Okay, something it's not happy with something. I don't know what it is. Let's just do it. X is equal to r uniform, r normal. The frame change another data. We have this. So r uniform int. Oh, I see. I see. You need to define a range. You need to define a range. So you can define something like, yeah. Okay, let's do it this way. Okay, now it works, right? So we have now generated two variables, some random variables. This could be an actual data. So if I say frame another data, summarize, we'll see we have the ID variables and we have some random normal variable and a uniform generated variable, which is from 1 to 10, right? And so again, we can do something like this. fr link 1 to 1 because it's a 1-to-1 merge. ID frame other another, right? So all observations matched, and then we generate this variable called another data. So this is, so if I do summarize another data, this is a variable generated with this by Stata that helps us link this to the other variable. So we do not modify this or change this. Yeah. But here's the important part. We can say generate underscore link. Tab underscore link. It will tell us which observations were linked. So this is our link variable, right? And these two variables, which are system generated, one should never touch or modify. Again, you can read the help file, but these are variables are which is telling us what's linked to what variable. But that's not the point. So in the other data set, we have these two variables, x1, x2. We can say fr get x1, x2 from link. And then we will say this has been copied to from linked frame. So we can copy variables from the other frame. We can even do something like fr2, fr get x1, x2 is equal to x1. Sorry, let's also, you can also do something like this. So we can say prefix underscore copy. We can also make sure that we are not duplicating stuff. So we can also prefix a copied variable to just to track them more easily. We can even do something like gen new var equals price over frval underscore link. So this is our link variable, and then we get x1 from the other data set, right? Fr value. And so we can not only copy over variables from linked frames, we can also pick up specific variables from linked frames and bring them over. And so again, going back to our initial example where we were looking at how to link different data sets. So this helps reduce the complexity or the size of the data set by just linking frames and pulling in the observations we need, right? And then again, if I say frames directory, we know that we have two frames. We can also save all this information. We can say frames save. We call it all my frames. This is the name of the save we get. Frame underscore all. These are also linked and replaced. And so what we do is we store this whole session, which we creates this dtas file, which is a new file type that helps us save our, let's say, session. Yeah, what is called sessions in R or similarly in Python is this session is saved, and then you can load this session. You can say frames use all my frames here, etc. And this will load your linked data sets and everything in one go. You can add frames, remove frames from this. There's a lot more one can do. And so, yeah, this is, let's say, a quick overview of stuff you can do with frames. Of course, it can get way more complex or way more interesting depending on your case. But the idea here was to showcase to you guys different ways of using frames for your workflow analysis.